All right, I think I'm recording. I'll find out pretty soon if I am or if I'm not. I wanted to go through Connect Math sections 1.6 and 1.7 because some of the questions, well, we're finally going to start graphing and using some Connect Math features. And I want everybody to be on board with that. So the first three questions of this set are asking you to identify parent functions. And there's no second chance on these. If you get it wrong, it won't let you try again. So square root, which of these is square root? Square root, come out. Yes, that's right. And let's check. Woo. What about here? We're looking for the cube function, the cubic function. Which of these is the cubic? Which of these is the cubic? That's right. Very good. In the elongated snake. Absolute value. Gee willikers. Are any of these graphs, whatever. Do any of these graphs match absolute value? Awesomely, yes. And then I think we start doing translations. So here's the square root function, and they're asking us to graph g of x, which is the square root of x, all plus 5. Remember, when they're adding or subtracting outside the function, you're going to move or slide vertically. We're going to use this tool, and it says translation tool. And I'm just going to grab the function. So I held my cursor down and dragged up until I've gone up 5 units. And now let's check. Yay. Okay, this is the cube root function, and they want us to multiply it by 6. That's going to be a vertical stretch, and that's this tool, vertical stretch or compression. And we're going to take this 1 and make it a 6. Let's check. Yay. It's being very slow. Here we go. Oh, this one is fun. So they're giving us 3 points on the graph, and they want us to graph 1/9 of that graph. So let's do something. Let's see if we can evaluate the function at the points. So what is y? If we're plugging in -9 here, what is the y? Excellent. Y is 0. So if I multiply 0 times 1/9, I still get 0. So the point will still be -9, 0. What about this point at 9, 0? Exactly right. It will stay 9, 0. The only one that will change is the point at 0, 9. If I multiply the number 9 by 1/9, I get 1. Now we're going to use this segment tool. And it really helps to have the points already plotted before you use the segment tool. You just click on one point and then click on the next point. I used the pencil to graph the points. Okay. Slow, 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 slow. Here we go. Okay, a negative outside of a function says reflect vertically, which means reflect with respect to the x-axis, and that's a vertical reflection. Okay, so we're going to tap on vertical reflection. This is the square root reflected vertically. Oh, this one is actually a lot of fun because we've got just 3 line segments. The first thing to do is to graph the endpoints. So let's see, what am I trying to do? I want to graph negative f of x, which means I want to change all of the y's to the opposite sign. We had -4, 1. That will become -4, -1. Then I'm going to pick up a solid dot. We have -1, -2. That will become 1, +2. And then we have 2, -2. That will become 2, +2. And 4, 0 stays 4, 0. Again, once you have the points plotted, the segments, it's easier to graph the segments. You click on one point, click on the second point, and then pick up another segment, click on one point, click on the second point. It looks right. Yay, okay. Here's a good first one. So we're going to do this in the same order we would do it on a test. The first thing I'm going to do is the horizontal translation. I'm adding 6 inside the function. Inside is always backward, so I'm going to subtract 6. So we go back 6 units. Now I'm going to reflect vertically because the negative is outside. So reflect vertically. And finally, I'm going to go vertically 3 units. Let's see, am I still at -6, +3? Okay, good. All right. We're going to do the same kind of thing again. So we've got a horizontal shift of -4. And then we've got a vertical stretch. So this point, -3, 1, I want that to become -3, 2, because we're multiplying by 2. Oops. There we go. And then I'm going to go vertically 3 units. 1, 2, 3, 3. Okay, let's try it. Yay. All right, same thing. We're going to take the absolute value, go right 4 units, multiply every point by 1/5. The easiest point to multiply by 1/5 is this point at -1, 5. I know that's going to be -1, 1. So I'm going to use this tool and drag down. And the 5 became a 1. And then I'm going to translate vertically. Okay, let's try it. Good. Here we've got, let's see, let's try another. I don't know why that's still there. Okay, good. So we've got 2 transformations here. We're going to go vertically, pardon me, horizontally 2 units to the left. 1, 2. And the negative next to the X says we're going to flip horizontally. So I'm going to use reflection across the Y-axis. Let's check. Cool. The next, oh, this one is fun. So they want us to write the function that does the following things. Stretches vertically by a factor of 7. Well, multiplying 1 over x times 7 will do that. Reflect across the x-axis. That means I want a negative outside, so -7 times 1 over x. And then shifts down 8 units. So -7 times 1 over x minus 8. So let's see. -7, and I'm just going to put it over x minus 8. Let's see if it will actually, let's see if it will accept -7. Oh, it won't let me, I see. So we have to put it over x. Minus 8. You see how that worked? Okay. Okay, the next several questions are about symmetry. And we looked at that in the lecture. So is this graph symmetric with respect to the x-axis, the y-axis, the origin, or nothing? And the way we can tell is we can substitute negative x in there for x. We've got negative x squared, which is the same as x squared. So it stays the same. If a graph stays the same, it is symmetric with respect to the y-axis. Here we've got a little bit of a different one, and we didn't talk about these yet. Oh, goodness. So if I let x be negative, how is this going to compare with the original? So here we've got y squared. That's going to be symmetric with respect to the x-axis. It's like we've got a square root with both parts. So I'm here. Now I am symmetric with respect to the x-axis, and we'll talk about that more in class. Even functions have symmetry with respect to, that's right, very good. Okay, is this graph even? Let's see, if it's even, we can fold it along the y-axis and it will match. It looks like it does not. If it's odd, that means it's symmetric with respect to the origin. So twice folding, and I can see it's not going to match. So it's going to be a neither. Now we're actually getting to do the algebra. So I've got 9 times. Oh, I guess I don't get to do the steps. Okay, so I'm actually going to change my share and do this on paper. So I've got k of x is equal to 9x cubed minus 3x, and I want to find k of negative x. Because this is really important and it's not trivial. So we're going to share the other camera. So if I plug negative x in for all of the x's, I get 9 times negative x, all to the third power minus 3 times. Instead of x, I'm going to put negative x. So every single place there's an x, I'm going to put parentheses and a negative x, parentheses and a negative x. And now let's work it out. Just this negative x cubed. Well, that's the same as negative x times negative x times negative x. The first two, let's see, negative times a negative is positive, and x times x is x squared. So we get positive x squared if we multiply 2 of them. X times x is x cubed. Let's see, times negative x. So we'll get x cubed. Positive times a negative is negative. So negative x, all quantity cubed is going to be negative x cubed. So this will be negative 9 times x cubed. And then the next term, we've got a negative times a negative. That's positive 3x. That's all they wanted. But what we're going to do is go ahead and see, does this function match our original? Definitely isn't the same. Let's factor out a negative and see if the remaining parts match. So negative 9 divided by negative 1 is positive 9x cubed. Positive 3 divided by negative 1 is negative 3x. Now, is this remainder the same as our original? Sure is. So that means that this function is symmetric with respect to the origin. It is odd, which is, these are saying the same thing. And we know that because since k of negative x was equal to the opposite of k of x. Cool. Let's go back to the homework. So let's type in negative 9x cubed plus 3x. That's exactly what k of negative x is. And we already saw that that is exactly the same as negative k of x. So k of x is positive 3x cubed minus 3x. Negative means I'm going to change both sides. So I have negative 9x cubed minus, plus 3x. And since those two match, they are equal, then we know that the function is odd, which means that it is symmetric with respect to the origin. Oh, I think I must be finished. Okay, groovy. So let's, that's all I wanted to do. I hope you're doing well. And actually, let's take a gander at 1.8. Here we go. Here we've got f minus g of x, and we're evaluating that when x is -7. So that means we've got f of -7 minus g of -7. Yeah, it looks like these are good to do on paper, and we'll do these in class together. And this is composition, which we have not looked at yet. So functions can come together in all the normal ways, adding, subtracting, multiplying, and dividing, but they also have a new way to combine, which is called, the word is composition, and it's this little circle. It is not multiplication, it is something different and special. Okay, I'm going to go ahead and close this and stop the video.